Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by gathering what matters: compute, data, and a model family. Get access to GPUs or cloud credits. You need memory and throughput. Once done, assemble a focused dataset and clean labels to avoid noisy signals. Make sure to select a model architecture that fits your goals: transformers for text, diffusion for images, because architecture affects training dynamics and cost. Now prepare a reproducible environment. Containerize dependencies and pin versions so you can iterate without breaking experiments. You move into training. Leverage pre-trained weights to shorten time and improve stability. Once initialized, fine-tune with mixed precision and gradient accumulation to fit larger batches. Make sure to implement a sensible learning rate schedule and warm-up. Abrupt changes destabilize training. Monitor metrics continuously, loss, validation samples, and gradient norms, and log checkpoints frequently so you can roll back. If quality lags, adjust data augmentation, regularization, or batch size, and iterate in small steps to isolate effects. You finish by optimizing and deploying your model. Quantize or prune for efficiency, then export to a production format like ONCs for serving. Once deployed, wrap the model with input validation, safety filters, and usage caps to protect users and budget. Make sure to /b test and monitor real-world performance and latency. Roll back if a variant underperforms. If things go wrong, first inspect data drift and learning rate, then check for overfitting and stale preprocessing. Those are the most common culprits.
Thanks for watching. Subscribe to keep your life in tune.